Hello, my name is Albert Abraham Michelson, and I was part of the Michelson-Morley experiment along with Edward Morley. So the goal of our Michelson-Morley experiment was to determine the effects of the luminiferous ether wind on Earth's surface. Now, luminiferous ether likely means nothing to people anymore, but before we knew about the dual nature of light, we knew only about its wave nature through experiments such as the double slit experiment. And we came to the conclusion that, like other waves, such as sound waves, it needed a medium to travel through, such as sound traveling through physical material mediums. But we knew that light traveled through space, such as from the sun to the earth, and there's no physical material medium for it to travel through there, so we decided that it had to travel through some ethereal medium, an ether. And due to light being what travels through it, it was designated the luminiferous ether. Now, the luminiferous ether was thought to be a static background of the universe, basically, where all the motion of the heavenly bodies could be considered as being in motion relative to it. And because of this, the Earth would be traveling through that ether, and on the surface of the Earth, an observer would witness the ether being moved at a constant rate, or semi-constant rate, depending on the Earth's velocity. This was designated the ether wind, and the effect of this ether wind is what we were attempting to detect in our Michelson-Morley experiment. The Michelson-Morley experiment, or at least a scientifically valid trial, happened at Cleveland, Ohio at Western Reserve University in July of 1887, where Morley was acting as a professor at the time. Well, of course, there were the ever-prevalent wars of the world happening, although the only one happening in the United States was the American Indian War, which lasted so long that you could ask any number of inventors who worked in America or scientists who worked in America, and all of them would probably say that the American Indian War was still going on. But the only one in terms of Germany where I've made my original experiment, the closest one I believe was the Serbo-Bulgarian War, which in terms of distance and US standards may be considered close, but in terms of European standards and the number of countries between us, it likely did not affect my work in the slightest. What did affect my work, though, was the growing interest in even consumers for waves and light technology. There were photo cameras being made, there were gramophones being patented, and there were even electric light bulbs being put into public use at this point. Even in Cleveland, Ohio, where the experiment took place, only 2 years after the experiment, electric light bulbs were being put into public infrastructure, which goes to show just how focused the world was on light at the time. Everything had to do with waves at the time. The other participant in the Michelson-Morley experiment was, of course, Edward Morley, as without him it would simply be the Michelson experiment. He was, an integral part of the design of the new apparatus, as the one that I had designed earlier for my experiment in Germany was not quite sensitive enough to detect the changes that we needed to detect. He also was an important part of the location, as he was actually the professor at Western Reserve University. I was, of course, the designer of the original experiment back in Germany, which fired a light into a half-silvered mirror, which split that light into two orthogonal directions, which means 90 degrees between each other, and that light was then bounced back into the mirror and recombined onto the same path into a photodetector. This detector detected the interference pattern between the two waves of light that were recombined. Now, this experiment sadly did have too many flaws for it to be considered rigorous, so it had to be redone, and this became the Michelson-Morley experiment. I was an important part of the design of this apparatus as well, although it's too complex to describe in detail, but it follows the same procedure as the other one, where light is split up, bounced through mirrors, except this one had many more mirrors in order to increase the path distance, which increased the sensitivity of the detector. And because of this, we actually had to float it on a pool of mercury, which stopped any outside interference from disrupting the signals that we were detecting. No matter which way we tried to measure the effect of the ether on the apparatus, we were never able to come to a conclusive result due to the fact that no matter how we oriented the apparatus, we continue to get the same interference pattern back every time. While this didn't immediately have any large impact, it did invalidate the theory of the ether that was made at the time, and left scientists trying to come up with new theories that involve the ether and our findings, until eventually the dual nature of light was found by Albert Einstein shortly before he invested himself into relativity instead. Well, first and foremost, I must admit that the problem is more so with me than with the apparatus, because I had predicted the change in the interference pattern to be twice what it actually should have been, and because of this, the apparatus was actually not sensitive enough to detect the change that it needed to, which invalidated the experiment and led to it having to be reworked into the Michelson-Morley experiment.